All right, let's dive into a massive question at the very heart of AI. Can our data ever really stay private? Today, we're going to pull back the curtain on a hidden vulnerability inside the AI models we use every single day. Think about it. Every search you make, every product it recommends, every single interaction you have with an AI is fueled by data. And a lot of the time, it's your data. We trust these systems to learn from it, right? But what if they're doing more than just learning? What if they're remembering? And that really gets to a fundamental question of trust. And that right there is the heart of the problem. It turns out that machine learning models, from the simple ones all the way up to those giant language models, can accidentally memorize specific, sensitive details from their training data. We're not just talking about learning general patterns here. We're talking about retaining individual data points. And that, well, that creates a huge privacy risk. So how on earth does an AI get a photographic memory like this? It's not like it's a feature someone programmed in. Nope, it's more like a bug, a really sneaky side effect of the way they're trained, which can open up a hidden backdoor for our private info to leak out. The main culprit here is a concept called overfitting. Okay, imagine a student who's cramming for a test. Instead of actually learning the material, they just memorize the exact answers to the practice questions. Sure, they'll ace those specific questions, but give them a new problem? They're lost. An overfitted AI model does pretty much the same thing. It gets so obsessed with the training data that it memorizes the examples instead of just learning the underlying rules. And this vulnerability, this tendency to basically memorize stuff, it can be exploited. And the tool that attackers use to do it is called a membership inference attack, or MIA. You can think of it as a way to kind of read an AI's mind and see what it remembers. So officially, what is a membership inference attack? It's basically a privacy stress test. An attacker has a really simple goal: to figure out if one specific piece of data, like say your personal medical record, was used in the giant pile of data that trained a specific AI model. Okay, so how do these attacks actually work? Well, they hunt for a giant flashing red light, a telltale sign of memorization. When a model sees data that it was trained on, it gets super confident in its predictions. It's like that student who memorized the answer. They don't hesitate, they just shout it out with 100% certainty. But for new data it's never seen, it's more of an educated guess. And that gap, that difference in confidence, that's everything. And hey, this isn't just a theory, it's a really well-documented thing. This quote here nails it perfectly. The model just acts differently depending on whether it's seen the data before. An attacker can use that little behavioral quirk to figure out what it's been trained on. So how do the bad guys systematically take advantage of this? Well, one of the most clever, most sophisticated methods is known as the shadow model attack. And honestly, it sounds like something straight out of a heist movie. It's a really slick, multi-step plan. First, the attacker trains their own shadow AIs that are built to act just like the target model. Then, they use these shadow models as a training ground, feeding them data they completely control. From this, they build a second attack model that gets really good at spotting that high-confidence signature of memorized data. And finally, they turn this powerful attack model on the real AI to see if your data was in its training set. And it's important to know these attacks can happen in a couple of different ways. The most common is a black box attack, where the attacker just has public access, like through an API. They can ask the AI questions and see the answers. But a white box attack is way more dangerous because the attacker has their hands on the model's inner workings, making it even easier to spot those weak points. Okay, I know this is all super technical, but let's get to the real question. Why should you care? This isn't just some abstract problem for researchers. It's a seriously high-stakes privacy risk for all of us. For you and me, the risks are, well, they're huge. If an attacker can figure out that your data was used to train a model for, say, a specific disease, they've just learned something incredibly private about your health. They could figure out your financial habits, your private social media behavior, or even piece together enough info for identity theft. Just proving you were part of a dataset can reveal a massive secret. And it's not just individuals at risk. For organizations, a successful attack like this is a total nightmare. It can absolutely destroy user trust and your brand's reputation, it can expose trade secrets, and it can lead to gigantic legal battles.
This is especially true now with generative AI, where proving a model was trained on copyrighted stuff is a really, really big deal.
But it's not all doom and gloom. The good news is that the security world is fighting back hard. There are some really powerful techniques being developed to lock down that AI data vault and build stronger, much more private models. The absolute gold standard for defense is a technique called differential privacy. The main idea here is to inject a very carefully measured amount of statistical noise, or randomness, into the model's training process. This noise basically acts like camouflage, making it mathematically almost impossible to see the contribution of any single person's data. Here's a great way to think about it. Differential privacy essentially makes an individual disappear into a statistical crowd. It becomes nearly impossible for an attacker to tell if any one specific person was in that crowd or not. It blurs the individual data points while keeping the overall patterns so the model can still learn what it needs to learn, but those inference attacks just fall flat. And that's not the only tool in the toolbox. There are other key defenses too. Things like data minimization, which is just a fancy way of saying only collect the data you absolutely need. Or output randomization, which messes with the attacker's main signal. There's also federated learning, which keeps your data on your own device. And of course, regularization, which is like teaching the AI good study habits to prevent that dangerous overfitting from ever happening. But the story doesn't stop there. Because just when we thought we were getting a handle on things, along came the giants, large language models. LLMs. And they've created a whole new frontier and a whole new challenge. You know, for years, the general thinking in the field was that LLMs were just too big to fail. They're trained on such ridiculously huge and diverse piles of data that the effect of any one document was thought to be so diluted, so tiny, that memorization just wasn't a real risk. And the early tests seemed to prove this. Researchers would try to attack these LLMs using really short bits of text, about 256 words, and the results were basically a coin flip. The attacks just didn't work at that small scale. But then, some new, groundbreaking research completely flipped that idea on its head. It turns out the attacks do work, you just have to think way, way bigger. Instead of looking at a tiny sentence, attackers are now piecing together all the subtle little signals from across entire documents, 10,000 words or more, or even across whole collections of documents. So here is the bottom line, the critical point to take away from this. That old assumption, it was wrong. You absolutely can successfully attack an LLM, but you can't do it by looking at just one sentence. You have to look at the whole book. And this discovery, it is a total game changer, especially for all those legal fights happening right now over whether LLMs were illegally trained on copyrighted books and articles. And this really brings us to where we are today, in an unfinished chapter of the AI story. It's a constant cat and mouse game between new attacks and new defenses. And as these AI models get more and more powerful and woven into every part of our lives, it makes you ask a really tough question. In this new world, is perfect data privacy even possible? That's a question I think we're all going to have to answer together.